In this video, we'll begin to look at the problems, the homework problems that deal with parallel and perpendicular lines. So again, in order to tell whether lines are parallel or perpendicular, we have to find their slopes, compare their slopes. If the slopes are the same, the lines are parallel. If they are opposite signs and reciprocals of one another, then they're going to be perpendicular. All right, so let's begin with the blue line here. So the equation of the blue line, the slope of the blue line, rather, we're going to go up 1, 2, 3, 4. Oh, sorry. That would be just up 3, right 2, which means that it's rise over run, m is equal to 3 over 2. For the red line, we're starting at the leftmost point. We're going to go down 2. So it's negative over right 1, 2, 3, 4. So down 2, m is equal to down 2, right 4, which is the same as negative 1/2. All right, for the green line, we start at the leftmost line, go up 1, 2, 3, 4, 5, then right 1, 2, 3. So the green line has a slope of 5 over 3. Now, interestingly, none of these lines are parallel and none of them are perpendicular. Now, the blue line and the green line may look parallel, but they are not. And so none of the lines are parallel, none parallel, none perpendicular. Explain. No slopes are the same or equal, and no slopes are opposite reciprocals. All right, we'll go on to the next. Problem number 15. We have 3 lines, and we're going to have to find their slopes using the slope formula. So we'll go to the blue line. To save space, I won't write the formulas here. We have 3 minus 1 over 0 minus negative 2, and that gives me a slope of 2 over 2, which is 1. So this one, first A, I should say, has a slope of 1. B, we'll do in red. M is equal to 4 minus 1 over 6 minus 4 is equal to 3 over 2. So the red line, m is equal to 3 over 2. The line C, we'll write that in green, m is equal to 1 minus 3 over 4 minus 1, which gives me a slope of 2, negative 2 over 3, and so m is equal to negative 2 over 3. Well, we can see that lines B and C are perpendicular. Lines B, C are perpendicular. Slopes are opposite and reciprocal. All right, so again, you should be able to, from graphs of lines, be able to identify the slope of each line and compare them. If the slopes are the same, the 2 lines are parallel. If the slopes are opposite reciprocals, we'll know that the lines are perpendicular. Sometimes we may be given lines expressed as a pair of points, and then we need to find the slope of each pair of points and then do the comparison on the slopes. Sometimes we're given, as in problem 17, we are given equations of lines that we'll have to put into y equals mx plus b form and compare the slopes that way. So with the first equation, we have 4x minus 3y is equal to 2. I subtract 4x on both sides. I get negative 3y is equal to negative 4x plus 2, divided by negative 3, divided by negative 3, and I end up with y is equal to negative 4 divided by negative 3 is just going to give me 4/3 x minus 2/3, and so the slope of line A is positive 4/3. Line B. Well, fortunately for line B, we don't have to do too much. We can see that line B, its slope is 4/3. Line C, we have 4y plus 3x is equal to 4. And subtract 3x, subtract 3x, we get 4y is equal to negative 3x plus 4, divide by 4, divide by 4, divide by 4, we end up with y is equal to negative 3/4x plus 1. So the slope of line C is negative 3/4. From this we can see lines A and B are parallel. Then lines A and C and B and C are perpendicular. So AC, AB, perpendicular. Right, and we'll go on to problems number 19 and 21. So here we're given an old equation or an old line, and we want a new line that is perpendicular to this. So old slope, in this case, is 1/2. Since we want to be perpendicular, we want a new slope that is opposite and reciprocal, or negative 2, passing through this point x1, y1. We use our point slope form, y minus y1 is equal to m times x minus x1. And we get y minus 10 is equal to our new slope, negative 2 times x minus 7, and distributing negative 2x plus 14, y minus 10, adding 10 to both sides, I end up with y is equal to negative 2x plus 24, and I know that I'm perpendicular because the original slope was 1/2, the new slope is negative 2. If I were to plug in my point, my x coordinate, and ask what is the y coordinate, so equation, when your x coordinate is 7, what is your y coordinate? Well, negative 2 times 7 is negative 14. Negative 14 plus 24 is equal to positive 10, and so we have the point 7, 10 on our line, which means that we've fulfilled the requirements. Alright, in the next equation, this time we're going to have to solve for y first. So 2y equals 8x minus 6. But fortunately, all we have to do is divide everything by 2. We end up with y is equal to 4x minus 3. So this is our, we'll say, our old slope is 4. But we want to be perpendicular to that, so our new slope must be negative 1/4, and our x1, y1 are negative 3, comma 3. So we'll plug these into our y minus y1 equals m times x minus x1, y minus 3 equals negative 1/4 x minus negative 3, which is x plus 3. So we get y minus 3 is negative 1/4 x minus 3/4. We're going to have to add 3 to both sides, and y is equal to negative 1/4 x, negative 3/4 plus 3. That's like saying, what is $3 minus 3/4? That would be $2.25. Or that would also be 9/4. $2.25 is equal to 9/4. And so that would be our equation. Y is negative 1/4 x plus 9/4. And that would be our answer there. So as our answer above was here. Alright, so let's see if we have time for the last two problems in this of this type. We'll stop this video at this point. So we did 13, 15, 17, 19, and 20.